Hello, this is Ryan, and this is recording for the assignment number three, machine learning. So for this machine learning, all the necessary code are already run. So now I'm not running anymore because it will have a lot of time for this. So all the packages and libraries already imported. Respawn. Okay, I'm not running it anymore. We get the images and then it show the images and then we change render shape is right here. So first of all we learn about the images that we're gonna work on, and then we're gonna do the convolutions with 2D kernel. So with the 2D kernels, by adding this, so I run this and then we have the compare of the both array, so which is the original array shape is 140 over 359, and the padded array shape is 142 added and then 361, and we apply the kernels into the array value using this. So this is a support function, like the support step to clarify the function that we gonna use later. So standard convolutions, so define functions to trim out the values between 0 to 255. So this step, we're gonna apply everything that we have at the above to do the define functions convert to the kernel. Excuse me. And we use the nested loops like below that we apply everything into this so that we can apply it later into our input data and apply into the model for neural network. So first of all, we try with the lie detection. So these are codes built within the problem. So I will just briefly explain that. So first of all, horizontal kernel, this one, the 222, and then we try to transfer the horizontal using the function that we built above with the kernel, the horizontal, and then we can see the image over here. It will show all the line that horizontal sketch. And then, so these come to the questions that we do the 45 degrees. We can see the 45 degrees is here. I'm sorry, 45 degrees is here. And then we can see that all the the lines with 45 degrees is here. And then we do 155 degree, which is this. Excuse me. As you can see, we apply with the functions and the kernel is 125 degree, perfectly defined. And then we will have the array. Sorry. Okay, so continue with this. We have the apply following kernels. So this is we do edge detection. So we can show the image over here using grades, and then our kernels is this is the kernel that we use, and then use another kernel as well. So these to detects all the edges, and then this final kernel apply into this. So we can see that all the edges of the car images has been shown here. And then we come to the part B of model building. So we import all the necessary packets and libraries, and then prepare the data set with using data validations. And so these transfer data validation, one hold encoded, so to ensure that we work well with the model when we use for the input. So we build a neural network with the first layers is the convert into 2D, and the second layers is mark pooling. The third layer is to flatten the image, and the fourth layers is the dense layer, and then the last layer is submap function, which is the output with 10 epochs, 128, and then we can see the model summary like this. So 5 layers, the last one is the output. It's this, and then total parameters that we use is 1 million 50,890, and the trainable parameters is the same things. We use everything, and then custom callback class for lodging. So we create a custom callback class to be called during the training. So this. we use a class custom callback, cross callback, and then we use this all epoch int, and then we use instantiate the custom callback, and then we train the network. So we create the history equals to the trend, and then we train again, train the network, and then this one define the function to float the results. As you can see that the network was running through 45 epoch. So this we can see the results of the training validations and the training accuracies and validation accuracy. Up to 45 is where it's running like half an hour, and then plotting the results, we can see that. So this is the validation accuracies, and this is the training. So the trainings keep increasing the accuracies over the number of epochs increase, but for the validation up to the number 10, it remains stable until the last epochs. So did it represent overfitting? Possibly, because there is a sign of overfitting, as we can see starting at the epoch number 10. The training accuracy increases, but the validation accuracies stay remaining stable, 0.65 around that, which meaning the model can predict the training model well but cannot perform well on a testing, which is the increase of number of epoch can cause to the overfitting for the testing dataset. So write out how many layers this model has and identify the type. So I already do the model summary again, and then we can see that we have 5 layers: convert 2D, max polling 2D, flatten dense, and dense 2, which is the output. So first of all, the first layers is convert 2D, extract the partial speeches from the images using convolutional filters that we have the formula, the functions over there. And then for the second layers, we reduce the number of dimension, the height and the width. So lower the computations and attract dominant features. And then for the third layers, we flatten the convert 2D into 1D vectors for fully connected layers. And the fourth layers, we have dense layers connected fully with 128 neurons to learn about the patterns. And then for the fifth layers, the dense layers, the output is 10 neurons, which is 10 classes of the validation testing data, and the softmax activations adds for multi-class qualification. So add one more convolutions layers to your model and run it again. So I added another second layer for the convo, which is 6433, the same, and then rel functions, but constraints also the same, only change in didn't change in the input step because this is the input layers, and then add another max polling 2D, and then we can see that the model was running again, and then the accuracy overall has increased with the accuracy for training decreases, but the accuracy for training it's increasing. So we can see here the image plotting that accuracy for validation increasing a little bit into 70 to 75%. And then we can make the comparisons between the two models that we added. This one is the one that we added, another complication, which is another layers, and this one is the original models that we have. So we can see that overall the second model has higher validation accuracy than the training accuracy. So overall, yes. And then specifically at the output number 0, the initial models start with 40 and 39 for the bigger model, so which is the same. And then comparing the training accuracy for both model, we can see that the training, the bigger model, which is the second model that we created, consistently achieves higher training accuracy across the outputs. We can see that consistently increasing the accuracies, but this one a little bit like slower. And then by epoch number 45, it reached 97.69 compared to the model number 1, which is 92.19%. meaning that the additional layers like more complication allow the model to better fit, but to only the training data. And comparing the validation accuracy, the second model has consistently outperformed the original, which is the peak is 73.75% at the airport number 40. And this model is peaking at 55 at the push number 20. So here, the improvement indicates that the added complexity to the actual layers help the model learn more about the features. And overfitting of the models could potentially because of the gap between the testing and the training validation. However, maybe this one has overfitting as well. After the number of inputs increase, have the overfitting. So now we add drop out layers to your model. Add to your models. So this one we add another layers, which is the dropout layers. I put the parameter is 0.5. So this parameter will be explained after all of this. So this we run the model again, and then after running, it is increasing in the accuracies. We can see that, but the gap is stable. We can see that the gap is different from the plot that we have below. So explain what is the dropout layers? So the purpose of the dropout layers is to prevent overfitting. The dropout layers help to introduce the noises into the network during training, which make the model more robust and less reliant into specific neurons, so that it can perform more correctly on the other model on the other data sets as well. So the ways that the dropout layers work is during the training, testing of parameters. So first of all, training during the training at each training step, the dropout layers randomly drop out, which means like set to zero the weights affections of neurons. It is in the layers applied to the step to ensure that all neurons of features can be considered for decision making. And during the testing, this function is off, which means it's inactive. The entire network can be weighed, and each of them can be joined into the process of classification and in the way so that the dropout attending ensure that the consistent prediction. And the parameter 0.5 mean that 50% of neural will be dropped out during the training by randomly as we explained. And that's all for the submission of the assignment number 3 for machine learning, and thank you for listening.